Good morning. Good morning, London. Welcome to the 2018 London Summit. My name is Pawan. I'm a technical account manager, and I'm excited to have Alex from Financial Times. And today we are going to talk about how do you actually gain operational controls and insights using Amazon Systems Manager. Just a show of hands, how many of you have actually used Systems Manager or heard of names of System Manager? Okay, roughly say about 10%. So that's one of your objective for today, to make you aware of what System Manager is and how you can actually use probably for some of the use cases. In terms of what you expect in this session, we'll see a quick introduction of Systems Manager, some of the components and use cases. Then we're going to have Alex, who's going to come on stage and talk about how they have been using Systems Manager in Financial Times. And we're going to have a demo as well. So hopefully it'll work. In terms of the content, we're going to have probably a full 45 minutes of, we're going to take the full hour. And in case if you have any questions, please come and find us after the session, and we'll be happy to answer your questions. So we've heard customers mention how cloud has become a new normal, and customers of all sizes are actually moving to the cloud. And with that move, they are actually able to gain the advantage what AWS Cloud offers in terms of increased agility, reduced cost, scalability, as well as a global reach. But there has been a refrain. We have seen customers trying to manage these resources that they deploy on AWS by themselves. As a first step, what they try to do is to bring their on-premises traditional tool sets to manage these resources. Perhaps they want to get a single pane of glass or the visibility into their resources running both on-premises as well as on cloud. Now, most of these traditional, we've heard customers mention the challenges around these as well. So most of these traditional tool sets are not actually designed for cloud scalable infrastructure. So when you have systems that scale up and down in a matter of few minutes, these tools traditionally don't cope quite well. And perhaps what they end up doing is having two separate set of tools, one probably to manage the AWS resources and the other one to manage on-premises resources. Now, as you see, it becomes quite complex and quite costly over the period of time. And most of the traditional tools does come with a licensing cost, usually per managed instance, so it becomes quite expensive as well. So we've heard this feedback from a lot of customers loud and clear. Managing cloud and hybrid environments using the traditional tool sets is quite complex and costly. So what we have done is we have heard those feedback from the customers and built and released the Systems Managers, AWS Systems Manager. So Systems Manager is a set of capability which helps you to perform ongoing operations and managements at scale. If you have heard about EC2 Systems Manager, so what we have done is we have taken some of the functionalities and features from there and launched it via the Systems Manager, and there are some additional new functionalities available as Systems Manager. Now, broadly, they are grouped into three categories. The first one is a group, which allows you to find resources and then group them in a logical containers. This could be like based upon your application stack, or this could be based upon your environment. The second one is a visualization or insights. This is basically to get a view of how your resources are doing across AWS as well as on-premises. And thirdly is take actions. So based upon the insights that you have gathered, what actions can you take is basically represents under the take action. So these are the remedial actions that you can actually take on the set of groups. Now, Systems Manager is cross-platform, which means that it actually supports multiple layers, multiple flavors of Linux, Red Hat, SUSE, CentOS, multiple flavors of Windows operating system. You can use it to manage resources both on-premises as well as on cloud, and it has native inbuilt support for other AWS services. Now, Systems Manager is available to you at no additional cost. So you might be charged for some of the resources like EC2 instances or some cost for the storage that you might be used for certain things like output or might be in inventory, but Systems Manager is made available for you at no additional charge. Now let's see some of the Systems Manager components and their use cases. Now the core to the Systems Manager is the Systems Manager agent. So this is the agent that you install on your operating system, which talks to the SSM service. And this is supported, or basically it supports multiple OS flavors, like I mentioned before. So we support multiple Linux flavors like Red Hat, SUSE, CentOS, and multiple Windows versions as well. Now, going a bit more detail into the different components, we saw the 3 buckets, which is basically the groups, visualization, and take. So that's expanded into groups, the resource groups. So this is a place where you would actually go about and discover your resources. So you can do a find operations either based upon your tag that you have defined on your environment, and then save those resource groups. Insights. So we have built-in dashboards, which gives you like built-in insights, certain things like CloudTrail, personal health dashboard, trusted advisor. So you'll be able to gather more insights from this. Not only this, you could also get like inventory and compliance related information as well. In terms of the capabilities, there are about 8 capabilities that comes as systems manager: run command, systems, state manager, maintenance, maintenance window, inventory, automation, parameter store. So let's see how all of these components or capabilities hanging together. So the core is a feature called as documents. So the documents is a set of instructions that you represent either or author either in YAML or in JSON format. So it basically has like actions what you want to do. And you would submit this particular document to a service like run command, where you will define saying, these are my fleet of servers, and I want to get these commands or documents executed on those set. State manager, patch manager, automation works in a pretty similar way. We'll have a detailed look as how they differ from each other. And we also have 3 other auxiliary services: parameter store, which is meant to store your secrets and share across services; inventory, which gives you information about your inventory details about the software, as well as maintenance window. So by the name, it helps you define a maintenance window and allows you to perform those changes. Now let's have a look at what is a document. So the document here in this example is in a JSON format. You have the schema versions defined, then you would have a description followed by a parameter. So parameter here serves as an input parameter that you would pass. In this case, it's actually trying to install a Windows feature. And then under the main steps is where you actually define the action. So the action here is a PowerShell script which you would execute to install a specific Windows feature. So that takes in the parameter that you specify, and it could be a feature like IIS or .NET framework. So it can be as simple as this document that we saw in the previous slide, or it could get as complex as this one. So in this is an example of a document in a YAML format. So again, you would have a schema version, description, and then the main steps. So main steps can be one or more actions. And in this particular case, we have a nested document, which is actually referencing another document. So you can have nested, that way you can have modularity and reusability built into these documents. In the second step, it's actually going to referencing a GitHub repository where I'm actually trying to download an Ansible playbook. And it's also having a reference to an SSM store where I have my access token present in here. In the third step, it's basically has got the Ansible playbook, and now you just go ahead and execute that playbook to do the operation. So it can be as simple as you want, or it can be as complex as we have seen in this example. So what you do next is either you take the document that you define, or you can take the out-of-box documents that is available as part of the systems manager, and you deliver it to a service, something like run command or state manager. So let's have a look at what run command actually is. So run command lets you securely manage run these documents across a fleet of servers. So these fleet of servers can be on premises as well as on AWS as well. The state manager works in a pretty similar way, except that the difference is any operations that you want to do on a periodic basis, you can actually use state manager to do that. So let's have a deeper look at what these two things are. So run command can be allowed to run or execute your documents across platforms. So you can run it on Linux or multiple flavors of Windows. The nice thing about run command is you actually don't need to enable any inbound ports, meaning you don't need to manage your RDS or SSH ports any longer. You can also define the rate thresholds, the maximum concurrency that you want to have. What I mean by that is, in case if you have a fleet of 10 servers, you can say what's the maximum concurrency or how many parallel executions can happen at a time across those 10 servers. And then you can define error thresholds as well, meaning that if it has encountered 1 error or 2 error, stop executing the run commands from then onwards. And it has support for CloudWatch events. This is something like, example would be if you want to perform an diagnostics or you want to do a forensics when your instance is about to be shut down. So you can actually use a CloudWatch event rule to perform along with the run command. Now, the run command also supports delegated access. So let's have a look at how you can actually give the fine-grained control. So here is an example of an IAM policy where you can have a restricted run command to execute on all your instances, provided it matches a tag. In this case, the tag is app web server. And you can also say that in the same example, you can also restrict on which documents you can actually execute the run command. So now if you think back, you don't need SSH access and RDP access. And using the fine-grained control, you can actually now decide who can run what and which commands on which instances. So quite cool use case. So some of the use cases for run command would be like, since you don't need the SSH or RDP access, that you can safely go ahead and disable that particular service. And then now you can translate all of those actions that you used to do while SSHing into a document and perhaps run that as a run command. One of the cool use cases that I've seen recently is chaos engineering. So how many of you are aware of chaos engineering? Cool, good set. So for those who don't know what chaos engineering is, so chaos engineering is a discipline of engineering where you perform experiments on your production system, on your distributed systems, to make sure that it actually is able to withstand a turbulent condition. So it could be an example would be like either you can go and shut down an instance and then see the overall behavior of your system, or you can introduce latency on your API and see how your system behaves over the period of time. So here is an example blocked by Kuldeep from Expedia, where he's actually using a document where he's using an IP table rule to simulate the packet drop behavior using a run command and executing across a fleet of servers. So pretty nice use case. Okay, moving on to the state manager. The state manager is all about maintaining consistency or consistent configuration and ensuring that you have you reduce the configuration drift. An example would be if you have a bunch of servers which gets spun up as part of your auto-scaling group, and you want to do an operations on those new instances which come up, which scale up and down, you can actually use something like a state manager. So it pretty much takes the same set of documents, either you author or out of the box, and then provide that as input to state manager, and then you can define a time frame saying how frequently you want these steps to be executed. An example would be like you have maybe an IS server logs or Apache web server logs that you want to ship to probably a centralized location like a CloudWatch, and then have a dashboards built on top of it. So you can actually do this using state manager. Moving on to the patch manager and compliance. So patch manager is a service which lets you perform patches on your operating systems on your servers, or either the servers or the instances running on AWS. Now it does this via a concept called as patch baseline. So patch baseline is a set of rules that you define in terms of what patches that your operating system vendor provides to you are approved to be installed on these servers. So you can have the patches based upon a product by severity, by classification, and also you can define a time approval or a time window. This basically is an example for this would be, let's say Microsoft release a critical patch, and you want it to, you want to have a time frame to wait for 7 days before those gets applied into your production environment. Whereas on the other hand, you might have a rule saying, okay, it's okay to install on your dev environment. So you can define how long it has to wait before it's applied to your systems. And you can also define patch exceptions. So things like, even though it has matched the rules, but certain patches which might have dependency to other components, you don't want to really go ahead and install that. So you can exclude those via the patch exceptions. And once you execute these patch via the patch manager, you can also get a compliance report of how your system looks like, how your patch across your estate looks like in terms of compliance. And you can get the missing patches by severity. It's queryable, so you can just run a query and get the answers to your questions. So one of the ways how you can actually execute this patch manager is via the maintenance window. So we all have systems where you want to perform changes. This is typically defined as a maintenance window where you may have a run book or and there would be somebody who would wake up in the night and perform these changes during this defined maintenance window. So the maintenance window takes those rules and schedules your operations in the time frame that you have defined and executes those tasks. It also has a capability where it can prioritize tasks. So what I mean by that is you can have a high priority task execute before your low priority task gets executed. And you can also do like rollback and define a timeout as well. Now moving on to the parameter store. So parameter store solves the problem of securely storing and sharing information. These could be like either secrets or API keys, your license codes, so on and so on. Rather than having these secrets or information in your database or in your configuration file and possibly running into the risk of getting those committed into your code repository, into your public code repository, you can actually use the parameter store. So parameter store, you can actually use either a key value pair or a key and a string or key and an encrypted string. So you can use a service like key management service, KMS service, to encrypt that string and store it in parameter store. It also allows you to organize parameters in form of hierarchies. So in this example, you can see dev, test, prod, and then you can say prod/app/something. So that way you can also have role-based access saying, so if you have a developer whom you don't want to give access to any of the parameters in production path, so you can use that role-based access to define that restriction. And you get full audit trail via the CloudTrail service. So you can get to know who has actually called a parameter store, get parameters API, and then perform the complete query on those. It also has native integrations with services like ECS, Lambda, Cold Build, and we have seen an example of how you can actually use the parameter store in your document itself. So moving on to the insights bits. So we have seen an example of compliance, how the compliance looks like. Let's have a look at the inventory dashboard. So inventory is a way for you to discover and audit your software. So it includes all your software versions, packages, hotfixes that you have installed, and you can use this information to perform security and incident analysis. So let's say that there is a high priority CVE that comes out, and then you want to know how many of your, or which of your, if you're running any of those vulnerable softwares in your infrastructure. So you can actually submit a query and get answers to those questions. So it can have a predefined types like application, network information, files, windows, etc. You can also publish custom inventory as well. One of the things that's built into it is the integration with AWS config. So AWS config is a service which allows to track the changes on a specific resource. So if you launch this particular service, it will give you a timeline view of what are the changes that has happened over the period of time. There's another feature called resource data sync. So customers have asked, how do we actually get information or inventory information, patch compliance report across regions, across accounts? So the resource data sync actually does that for you. Cool. So let's switch to the demo. Let's wait a bit. Okay, there we go. Thank you. Cool. So this is the console view of AWS Systems Manager. So the first one is groups. So in here, you can actually go ahead and discover the groups that you have. So you can actually submit a query like, let's say I'm interested to know all my EC2 instances with a tag which says environment and prod. And then I can submit a query, and it will list down all the resources which are tagged that way. And I can also save this particular query as a group. So these resources or these resource groups basically are the first class objects of AWS. That means that you can actually enable tagging on these groups as well. So I have an example of a saved query. So it does pretty much the same thing. And once I go there, it lists down all my instances which match that specific tag. And I can do further operations like here, basically I can do a copy snapshot or create a snapshot or shut down an instance from right from this place. Moving on to managed instance. So these are the instances which have SSM agent enabled on them. Either it could be you could use an AMI which has support for the SSM agent, either if you're using a Windows AMI or an Amazon Linux, or you could also install these agents on your on-premises servers, and once it's activated, it will show up on this list. So that's a managed instances. Now let's have a look at your documents. So the documents can be found down here under shared resources, and these are the list of documents which are predefined and comes out of the box along with the systems manager. So let's have a look. I can further query and narrow it down to some of the documents which I have built. So let's have a look at one of these. This is a pretty simple document which actually lists an open port running on either Windows or Linux. So if I move to the content view of it, so this is represented in JSON format where I don't have any input parameters, but it's having a main steps, and it has more than one actions here. So the first action is matching a condition which says if the platform type is Windows, then execute this particular command, and if it matches another platform, then execute a different set of command. So now I have this document. So what I'll do is I'll use a service like run command to execute that document. So let's say I go to the run command, choose this instance or to choose this document, and here is the targets which is presented to me. So either I can select by tags or I can manually select an instance. So in this case, let's say just for the demo, I'm going to select a couple of instances here. And then I can also specify the rate control. So this is basically telling how many instances, how many executions can happen in parallel. So if you want to do that rate control that don't run X number of tasks on these particular set of fleet of instance servers. And you can also output, so by default it provides an output in the console. However, you can actually write that output into your S3 bucket as well in case if you want to do further analysis on top of it. Let's go ahead and execute it. And I get a command ID, and if I go back, I should see it in progress. And I have a success here, and while it's executing for the other one. So let's have a look at what the output looks like. So in here, I can have a look at the output. So what this means is I have two commands or two actions defined in my document. So it has skipped the Linux because this is a Windows instance. And if I go to the second output, it actually lists all the open ports on my Windows operating system. Now, the state manager also works in a pretty similar way, where first you create something like an association and input your document. An example would be like, in case if you have instances which are scaling up and down and you want to ensure all your SSM agents are updated frequently, or to make it sure that they are all consistent, and then reduce that configuration diff that I was talking about. So you can create an association here. There is a built-in out-of-the-box document called update SSM agent. And now I can say I want to ensure all my systems which match the tag environment production. This particular state manager should execute those tasks on this particular tag. And I can say go ahead and execute this every 1 hour, or maybe like a specific time of the day as well. And then basically create an association, and this will perform that operation in a repeated format. Moving on to Patch Manager. So Patch Manager works with a concept called as a patch baseline. So there are a few patch baselines which comes as default. So let's have a look at the default baseline, which is basically for Windows. So you have a default baseline for each of the operating systems here. So you have for SUSE, you have for Ubuntu, Amazon Linux. So what this specifies is the approval rule. So here we specify that it matches you're not specifying any specific product type, so it's a star, and then you group it by classification. So classification matching critical updates or security updates, and the severity by critical or important. And wait for 7 days before you can go ahead and apply these patches. So in case if you don't want to use this default baseline, you can actually go ahead and create your own baseline as well. So where I have an example here which says go ahead and match, use the product of Windows Server 2012. And if it is for a critical updates, go ahead and install that. Don't wait for any approval. Just go ahead and install it within 0 days. However, if there is a security update, then go ahead and perform this activity or this task in next 2 days. So once you have your patch baseline defined, you can go ahead and create maintenance window. So let's see an example of how you can define a maintenance window. So I can say, give it a name. And then I specify unregistered targets. So these targets are basically saying that anything that doesn't match this condition, go ahead and apply this on all the unregistered targets. And then I can have a cron or a schedule of these maintenance windows. So let's say I want to perform this operation every Saturday, perhaps at 1 a.m. in the morning. And I have to specify the duration as well. This duration is basically how long is your change window. So let's say, for example, 6 hours. And then stop initiating your task. So this is saying how long before your change window completes, you stop executing those patches or those changes that you wanted that you're performing. So let's say 1 hour before your change window completes, I want to stop all the executions. And then you go ahead and create your maintenance window. And once that's done, now you have to define your tasks as what exactly you want to do during your change window or during your maintenance window. So I can do a few things here. I can do like an automation task, or I can have a Lambda functions or a step functions to perform any coordinated stuff. But let's say I want to do a run command operation here. And there is a predefined document that I can use to, that's called as run patch baseline. So what this does is it looks at the set of patch baselines that we have and then execute them, evaluate them, and then make sure those are all applied on your instances, matching those rules conditions. And this is where I define your task priority, select your unregistered tasks, say select all of them. And then I define my concurrency targets or in terms of percentage. I also need to define a role here, and then register that task. Let's say 2, 1. Cool. So that's all you have to do so what in summary what we have done is we have defined a patch baseline. And then we have created a maintenance window telling when exactly you can actually go ahead and start performing those changes in the scheduled time. And then you register a task as what exact operation you want to do. So once this is executed, you can actually go to the insights. So under insights, you have built-in insights. These are the other AWS services. The first one is AWS config, which actually allows you to see the changes that has happened over the period of time. So it gives you a nice timeline view of what changes, exactly what are the details, what changes went in. You can also get an information of your cloud trail as well. These logs all the API operations that I've performed on a set of instances. Then you have personal health dashboard as well as trusted advisor. So we have a booth just outside in case if you want to get a demo of how Trusted Advisor works and how you can actually go ahead and set up automations to rectify those tasks. So you please stop by at the operations booth that we have at this level. Talking about the compliance first. So once you've got that maintenance window going in where you have all those patches executed, you can then come to the patch compliance report here, which actually gives you a summary of how your patch estate looks like. So right now in this example, I don't have any non-compliant systems here, so everything looks good. But you can actually also use this particular area here to submit queries like, let's say I'm interested to know if there are any patches that has failed, and I can submit a query, something like this, saying, give me any patches which has failed or any patches that are missing from here. So I can easily submit a query and get answers to it. So moving on to the inventory. So this gives you the audit information of various softwares that are running. There are a few default graphical views in here. that shows you what are the top 5 OSs that are using top 5 applications. You can also submit a query, which we have seen similar to the one in the past. Now, customers have asked, like, how do you actually get these patch compliance information or the inventory details across accounts or across Okay. So across accounts or across regions. So one of the ways to do that is by using resource data sync. So here is an example where I am created a resource data sync which actually logs all those information into a centralized bucket. So in my case, I'm using an Ireland region here, but I have created a bucket which is in US East 1. So all the resources that are running across accounts, across my regions are all dumped into this particular bucket. And from there, I can use other services like Athena, or probably I can feed that data into Elastic Search and then have a Kibana dashboard, or maybe use a dashboard like QuickSight to get visualization on top of it. Having said that, I'm excited to, it's my pleasure to invite Alex on stage, who is going to talk about how they have used Systems Manager in FT and give a more deep dive details into these features.
Thanks, Pawan. Hello, everyone. I'm Alex Kinane. I'm a security engineer at the Financial Times. The Financial Times is an international daily newspaper staffed by around 2,500 people with over 900,000 subscribers. We built a tool called Security Inventory. It allows us to monitor and report on the estate of the compliance estate, on the compliance status of our estate, and I'm going to tell you how it works and what it gives the FT. All software has bugs. When they are found and fixed, an update is released. When an update fixes a bug that could compromise the security of a system, it's given a unique ID. This ID is called a Common Vulnerability and Exposures Entry, or CVE for short. This ID allows people to track the details of that specific vulnerability, how it works, and any information about how to mitigate it, and if patches are available to fix the vulnerability. When a CVE is analyzed, it's also given a rating called a CVES score. This score is a number between 0 and 10 describing how bad the vulnerability, with 10 being the most severe. This score takes into account how the attack is performed, what level of access is required, how difficult it is to perform, and how many script kiddies are currently using it. For example, the WannaCry crypto worm leveraged the exploit known as Eternal Blue and was given a CVES score of 8.1. In the last year, there have been some of the largest security incidents ever. These have involved exploiting software with publicly disclosed vulnerabilities that could have been prevented if the systems involved were up to date with the latest patches. That's the driver for this project. We wanted to be able to answer questions about the patch compliance of our estate. Are we vulnerable to the exploit Eternal Blue? What's the oldest version of Java we have running in our estate, because old versions tend to have more vulnerabilities? How many Linux instances need the latest kernel update? We wanted to know this information about all of our systems. We have multiple AWS accounts. Teams get their own accounts to work in. This lets us delegate responsibility of small sections of the estate to the teams. They get to control what they do in their accounts within reason and can be insulated from the choices that other teams make. We're a global news organization with staff and readers located around the world, and because of this, we maintain several regional data centers alongside our cloud infrastructure. In AWS and our data centers, we run a combination of both Windows and Linux servers. We also have Windows desktops, Apple laptops, and Cisco network devices. They all need to be reported on. We wanted to have a unified view of patching across all of our different platforms and these different device types. So how to go about this? Our aim with this tool would be to better understand the risks associated with our estate. Once we know and can understand the risks, we can better manage the time and effort required to mitigate them, and if there is a new patch out that fixes a critical issue like Meltdown or Spectre. We want to be able to put the right amount of effort into fixing it, knowing which systems are affected and help us make those decisions. For us, the best way to approach data is to visualize it. We find dashboards are great for this. They allow us to track metrics and see trends. They're easy to share with other people, and they drive conversations and change, and they look really cool too. We build dashboards for everything that matters, from the uptime and load on servers, hit rates on ft.com, and the completion rates for staff training. There are even dashboards that show the weather. When we're discussing which solutions to use for different parts of the tool, we followed this simple processing model. We first have to collect the data from our different sources. We might then need to process or transform it in some way so that it's all in a consistent format. We need to have a central location to store all our data, and once we have the data, we can then start querying it for the answers that we want. We need a way to display these answers. What's the right approach for this? We have a lot of existing tools that all collect data for their specific realm. They have segments of the data we need, but not everything. We also looked externally to buy a product or tool to do this, but we couldn't find something that covered all the platforms that we needed, and those we could find were either too immature, too expensive, or not ready for enterprise-sized organizations. We could build something like this, but it sounds like a complicated problem, and it has a lot of moving parts. Development could be slow and expensive. There wasn't a single solution to this problem, so we ended up using a combination of all these approaches. So some of the existing tools that we used SolarWinds. It's a network monitoring tool. It knows about all of our Cisco devices and it talks to them over SNMP. It collects health, operational, and metadata. Luckily for us, it also collects the iOS version of the installed devices. We're going to need this going forward. We use Jamf to manage our Apple estate. Jamf is an enterprise management platform. It allows us to define policies and set up information centrally. It also lets us run reports on the installed software and the Apple laptops. We can use this as a data source. Graphite and Grafana are great for displaying time series information. If you want to graph something over time, then this should be your go-to tool. It really makes beautiful graphs and it's very easy to use. We also use Splunk. Splunk is a security incident and event management tool. It allows us to centrally store, search, and correlate log events from all our different sources, helping us quickly find the root cause of a problem. Of course, we use some AWS services as well. We used Systems Manager, or SSM. This is going to do the bulk of the collection work for us. This lets us gather the metadata we need and query our instances about their required updates. By using this, we never have to connect to a server to get the data we need. It's all handled by the service. S3 for storage. It's highly available, highly durable, and very easy to use. Athena, which is Amazon's offering of Facebook's Presto. It's a distributed database engine and allows us to process data straight from S3 and have lightning-fast query results. And of course, we use Lambda to glue it all together. These different components, we have lots of different integrations with existing tools, and there's some account-specific actions that need to be done. Lambda is the perfect choice for this, as it allows us to run our code without having to worry about the infrastructure that it's on. Here is a detailed view of the architecture we created. I appreciate that this slide might be a bit hard to read at the back, but don't worry, I'll break this down over the next few slides as well. SSM will do the bulk of the collection for us. We can use it to collect the data from our Windows and Linux servers, both in the AWS cloud and our on-premise servers. The instances will be registered to the SSM service in the individual teams' accounts, and this allows those teams to make full use of the service to manage their own instances. The SSM services will use the resource sync operation to store their data in our central S3 bucket. For SolarWinds, we will use a Lambda to collect the metadata from the iOS version from our network devices, and then we'll process those versions using Cisco's Open Vulnerability API to work out if iOS needs updating. We'll use another Lambda to collect and patch the status of all our Apple laptops from the Jamf API. Both of these Lambdas will store the data in a central S3 bucket, and then once we have all this data in S3, we can query it using normal SQL queries via Athena. We execute these queries on a schedule using Lambda and then pipe the results to Grafana for display. So here's the SSM configuration for our individual AWS accounts. We first had to install the SSM agent on all of our instances. We used PowerShell to do it on the Windows hosts, Red Hat Satellite for our RHEL boxes, and Ansible for the Amazon Linux instances. We also modified the instance's IAM role so that it could connect to our SSM service. We then created two associations. These are scheduled tasks that run against any instance that has the correct target tag. The associations we schedule are inventory and run patch baseline. Inventory collects the metadata for an instance and all the installed applications, and run patch baseline determines which patches need to be installed on an individual instance, and if any of those patches fix a known CVE. We use a baseline document to control the criteria for applicable patches. The SSM agent runs these associations, sends the output back to the SSM service, where it is then resource synced to our central S3 bucket. Running the inventory association on an instance will collect all the metadata available to it. This metadata includes computer name, IAM role, platform type, networking data, and hardware information. It will also collect a list of all the installed packages or applications. On Windows, this is the list from the add and remove programs control panel, and on Linux, it's the output of RPM-QA. The run patch baseline association allows us to compare the installed software to the latest available versions and determine if an update is needed. Using a baseline document, we can specify wait times before patches that fix a specific CVES score range are applied. In this example, you can see that patches that fix a bug with a CVES level of critical are to be applied immediately, whereas a patch marked as fixing a high severity bug is applied after 1 day. We are able to define different baseline documents for different operating systems, and we can also define different baseline documents for different environments. This allows us to have one rule for our development environments and another rule for our production environments. When the agent generates this information and returns it to the SSM service, it calls the information about the individual updates compliance items, and it calls the overall rolled up state of the instance compliance summary. We create our baseline documents in accordance with the FT's patching policy, and then this compliance data is resource synced and stored in our central S3 bucket. Our on-premise servers are configured in a very similar way to our cloud instances. However, instead of being registered to a team's AWS account, they're registered to the accounts of the Windows and Linux administration teams, who are responsible for the service maintenance. Just like our cloud instances, our on-premise servers have an SSM agent and collect the same data from the SSM associations. All of our switches and routers are registered in SolarWinds. We can collect this data using the Orion API. SolarWinds has the version numbers of the iOS software running on our network devices, but it doesn't have any information about updated versions on known CVE vulnerabilities. Luckily, we can look up each of our iOS versions using the Cisco Open Vulnerability API, and we can find out if there are any updates available, which CVEs they resolve, and the CVSS scores associated with those updates. We then transform this data to the same compliance item and compliance summary formats that the SSM service produces and store this data in our S3 bucket with the rest of the SSM data. It is now ready for querying as if the switches and routers were other cloud instances. We do the same thing with our Macs. Using the Jamf API, we can retrieve all the metadata we need to determine patch compliance and transform this data to the compliance item and compliance summary format and store it directly in our S3 bucket. We don't need to perform any additional lookups for this version information, as Jamf has everything we need. All our team's accounts now have all their instances registered with SSM. They are also collecting inventory and compliance information. This allows them to work with the SSM service and the compliance data however they choose. They can view the reports using the AWS console, schedule their own associations, or just use SSM to launch ad hoc commands on their instances. This means they still control their own accounts, and we have all the compliance data stored centrally. In our S3 bucket, the data is stored using a directory hierarchy, expressing the source of the information. It includes the account, the region, and the instance that produced the data. Everything is stored in JSON format. Now we have all of our data collected, it's time to extract some meaning from it. We first have to set up Athena to read our data. We can use the keys from the JSON files to create a database schema, and then this lets Athena access our data as if it was a standard database and not a bunch of JSON files just stored in an S3 bucket. Athena is really meant for really, really big data. Facebook say they use Presto to query a 300 petabyte data store. At that scale, you might have to wait a while for your results. So Athena is normally an asynchronous process. You execute a query, wait a while, and then go back and ask for the results. You get a link to a file in S3, download that file, and hopefully it has the results of your query in it. With our inventory information, which isn't 300 petabytes, Athena queries normally return within a few seconds. Because of this, we created a wrapper around Athena and S3 to make it behave more like a normal synchronous database. This made writing the rest of the application much easier while letting us query data directly from S3. Using our client, we are now able to run queries like this against our stored compliance data. We can write vanilla SQL to answer the questions we wanted to know about our estate, and here is an example query we run. First of all, we ask for accounts of all the entries from the compliance summary table, where they are in the non-compliant state, the critical severity level. This is the total number of devices that currently have a critically classed CVE. We are now able to answer questions like this. How many devices do we have missing critical updates? What percentage of our estate is patch compliant? And because it's SQL, we can quickly write any new query we need. Whenever an incident or event happens, we can spend a few minutes writing a query and then have the data that we need to start debugging or investigating a problem. Now we have these query results, we can display the data using Grafana. Here are some of the graphs we can generate. I can't give any context into exactly what they show or give you any indication of the scales involved, but I can say things are looking better than they were. So the results of this project. This tool has given us a lot of insight into our estate. We understand which systems are and which systems are not patched, and what the risk of these unpatched systems are. We have a dashboard showing 20 distinct metrics. This helps us focus our efforts on teams and systems that need the most help to mitigate risk. We get alarms for missing updates so we can prompt other teams to patch and stay on top of any critical zero-day vulnerabilities. 2 other teams are using this data for their own dashboards, giving them insight into their own systems. And it has really highlighted the benefits of automatic patching. The systems where this is implemented are much healthier than the systems without it. It's a lot of work to patch everything all of the time, and this has to be automated. This tool has driven changes to patch management across the organization. It's encouraging teams to build automated patching solutions and helping decrease time to patch metrics across our estate. We're hiring. If you'd like to come and work with us at the Financial Times, please check out our careers site for more information. Thank you for your time.
Thank you, Alex. Just to recap, basically you can use System Manager as a platform to automate your IT operations. It has integration with other AWS services like IAM, CloudTrail, CloudWatch, various other services to provide you automation and visibility. It's available across all AWS regions as well as accessible via AWS private link. So this is a way how you can actually create a private network between your resources running in your VPCs to AWS services, the supported AWS services. The SSM agent is by default on Windows Server as well as on the Amazon Linux AMI, and it is SOC and HIPAA compliant. So I hope you have got a pretty decent idea about what system managers are, and hopefully it will solve some of your use cases. So with that, thank you. Thank you all.